So these are the lesson 6.2 activities. Number 1, we have two vectors, u1 and u2, and we want to show that they form an orthonormal basis for R2. Okay, so orthonormal, that means I have two things to show: that they're an orthogonal set and that each vector has length 1, right? So orthogonal, length 1. And then we also have to show it's a basis, and that involves two things: linearly independent and spanning R2 to be a basis for R2. Okay, so I have 4 things I need to show. So I'm going to label them 1, 2, 3, 4. Okay, so number 1, to show that they're orthogonal, we dot product them. Okay, so I'm going to get negative 1 over root 5 times 2 over root 5 is negative 2/5. And then plus 2 over root 5 times 1 over root 5 is 2/5. I get 0. That shows me that they're orthogonal. Their dot product is 0. Okay, and then the length, to show the length of each vector is 1, you dot product with itself and square root. So I'm going to get negative 1 over root 5 times negative 1 over root 5 plus 2 over root 5 times 2 over root 5. And I'm going to take the square root of that. That's the length of u1. So that's going to be 1 over 5 plus 4 over 5 is 5 over 5, 1. That is the length of u1. Okay, and then the length of u2 is going to be the square root of 2 over root 5 squared plus 1 over root 5 squared, which is going to give me, again, the square root of 5 over 5, which is 1. All right, so both vectors have a length of 1. So we've shown orthogonal, and they have length 1, so that's an orthonormal set. To show it's a basis for R2, we have to show that these two vectors are linearly independent and that they span R2. So I could put them in a matrix, right? I could just do negative 1 over root 5, 2 over root 5, 2 over root 5, 1 over root 5, row reduce. And for linear independence, I'm looking for a pivot in every column. And for spanning R2, I'm looking for a pivot in every row. And it turns out when I row reduce this, I get the identity, which tells me that this is linearly independent and spans R2, which means they form a basis for R2. Okay, number 2. Let y be the vector 5, negative 4, and let L be the line through the vector 1, 0, and the origin. All right, so I'm just going to draw this before I even read the next sentence. So y is 5, negative 4. That's my vector y. And then L is a line through 1, 0, and the origin. So that's the x-axis. So this is my line L. And then the 5, negative 4, that's a vector, not just a point. So I'm going to connect this. Okay. Draw the orthogonal projection of y onto L. Okay, so that would be this vector. That's the orthogonal projection of y onto L, is this point. Okay. So I'm looking at this vector. The orthogonal projection of y onto L, also known as y hat. Okay, so we want to use your picture to write y as the sum of two orthogonal vectors, one in the span of u and the other orthogonal to u. Okay, so the one in the span of u, we usually call that y hat. And the other one orthogonal to u, we usually call that z. Okay, so this one is z. So just using my picture, I'm going to write y, which is 5, -4, as y hat plus z. Okay, and y hat looks like it is 5, 0. And that means z is 0, -4. Okay, so I've drawn it in a strange place in the plane here, 0, -4. But if you shift the starting spot of the vector right there to the origin, it's 0, -4. Because we usually draw vectors starting at the origin. So that is true. 5, 0 plus 0, -4 is 5, -4. All right, so that is pretty straightforward because that's how we typically break vectors down into their horizontal and vertical components. What this section shows is that you can break it down into any two orthogonal vectors. It doesn't have to be horizontal and vertical. It can be any two orthogonal vectors. But I'm going to use the formulas from this section to prove that to get the same thing, to get the y hat and the z. Okay, so my formula for y hat is y dot u over u dot u times u. Okay, so y hat, this is my formula. It's y dotted with u over u dotted with u, all times the vector u. Okay, so y was the original given vector, 5, -4. Okay. U is the vector on the line L. It can be any vector on the line L. We're going to use 1, 0. That was the one that was given. Over 1, 0 dotted with 1, 0 times 1, 0. Okay, so this is going to be 5 over 1. So 5, -4 dotted with 1, 0 is 5. And 1, 0 dotted with 1, 0 is 1. So we get 5 times 1, 0 is 5, 0. The same thing we got when we just did it via picture. All right, and then z, we calculate just by knowing that y needs to be written as y hat plus z. And now I know two of the three components here. So y is 5, -4. Y hat is 5, 0. So now I can figure out what has to go in z to make this. So this would have to be 0, -4. So the formulas get me the same thing. Okay. And y hat, that is the vector in the span of u. Because it's a multiple of 1, 0. And this one is orthogonal to the span of u. Okay, do another one. Y is the vector 7, 6. L is the span of the vector 2, 1. So all multiples of the vector 2, 1, which would be a line in R2. We're going to compute the orthogonal projection of y onto L using each of the following vectors from L. So I picked two different vectors from the span of 2, 1. 2, 1 and 4, 2. So this is to show you that you can use either one. You'll get the same thing as for y hat. Okay, so y hat is y dot u over u dot u times u. So 7, 6, dotted with 2, 1, over 2, 1, dotted with 2, 1, times 2, 1. All right, so I have 14 plus 6 is 20, over 4 plus 1 is 5, times 2, 1. So that's 4 times 2, 1, which is 8, 4. So there's my y hat when I use 2, 1 from the line L. And then I'm going to do the same calculation if I use 4, 2. Okay, so y dot u, so that's y. U is 4, 2, over 4, 2, dotted with 4, 2, times 4, 2. Okay, so now I get 7 times 4 is 28, plus 12 is 40, and 16 plus 4 is 20, times 4, 2. So I have 2 times 4, 2, which is 8, 4. Exact same answer I got before. Okay, so this problem is just to show you that you can pick any vector in the span to calculate y hat. And then your z calculation, you just do a quick subtraction. So we know that y, 7, 6, has to be written as y hat, 8, 4, plus z. Okay, so 8 plus what gives you the 7? -1. And 4 plus what gives you 6? 2. So there's my z. That is it for these activities.